Okay, so today we are going to be solving quadratics by factoring. So we started off using a table, and using the table is pretty labor intensive. So there's a lot of work involved to graph it. So if it can factor, factoring is a great way to solve and graph. So we solve quadratic functions to find the zeros. Just a little background information. Which zeros have a lot of different names. So they can be called the roots, the X-intercepts, or solutions. So if they say find the X-intercepts, that's the same thing as solutions, roots, and zeros. Or if they say the roots, so in a test question, they could use any one of those four terms, and that's what they mean. They mean the X-intercepts. Okay, and so we've already been talking about X-intercepts. So if you remember, every X-intercept has a Y value of 0. So to find the zeros, you plug in 0 for Y and solve. Okay, so let's look at an example. So solve Y equals x squared plus 3x plus 2. It's going to be a little bit tight because I wasn't supposed to skip a line there. Try to squeeze it all in on this one page. So the first step is we said we're trying to solve for the x-intercepts, right? The zeros are the x-intercepts. So we know that every x-intercept has a y value of 0. So the first step to solving for the x-intercepts is to plug in 0 for y. So instead of writing that y, we're going to have 0 equals x squared plus 3x plus 2. Once we do that, we are going to factor. So we have x squared, we have 3x, and we have 2. So what multiplies to give us x squared? That's x and x. Now what multiplies to 2 and adds to 3? That's nice, there's only one option. Positive 2 and positive 1, because x times 2 will give us 2x, and 1 times x will give us 1x. And those do, they combine to form that 3x. So our factors are x plus 1 times x plus 2. So next, we are going to set each factor equal to 0 and solve for x. because we know that 0 equals x plus 1 times x plus 2. If we substitute in our factored expression. So 0 equals x plus 1 times x plus 2. So then if we know that x plus 1 has to equal 0. We set that equal to 0, and then we set our other factor, which is x plus 2, set that one equal to 0, and then we solve. So we would subtract 1 from both sides. Those cancel out, leaving us with x equals -1. And so when x is -1, y is 0, because we plugged in 0 for y. Then we solve our second one, so we subtract 2 from both sides. The 2's cancel out, so x equals -2, and so our other point, our other x-intercept is -2, 0. So we have two x-intercepts because it's a parabola. So this parabola crosses the x-intercept 2 times. Okay, let's go ahead and look at your assignment. Okay, so we're just going to follow the steps that we just went over. So first we need to plug in 0 for y, but on the assignment I already did that for you. So it's already set to 0, and so we'll pick up at factoring. So now we are just going to factor. And so we have n squared plus n minus 20. And so what multiplies to give us n squared? N and n. Now this is a 1n. So what multiplies to -20 and adds to +1? So let's see, we could do 10 and 2 with one of them being negative, or 5 and 4. So 5 and 4 is going to get us that 1n. So it's a positive, so I think we're going to want the 4 to be negative, because that will leave us. So let's put the +5 there and the -4 there. If we multiply -4 times n, we get -4n and n times 5, which gives us 5n. And those combine to give us our +1n. Perfect. So we now have our factors, n minus 4 times n plus 5. We know that those equal 0. So now we're going to set each factor equal to 0 and solve for x. So our first factor, n minus 4, equals 0, and then n plus 5 equals 0. So we add 4 to both sides, and n equals 4. So our point, our x-intercept is 4, 0. Then we solve for n over here by subtracting 5 from both sides, and n equals -5. So our other point, our other x-intercept, is -5, 0. Okay, so you're going to go ahead and do that for the rest of the problems on this assignment.